Now consider case of two external circles neither intersecting nor touching. For that, consider two circles x1 minus x1 square plus y1 minus y1 square is equal to r1 square, and x1 minus x2 square plus y1 minus y2 square is equal to r2 square. Let's draw these two circles. This is circle S1 and this is circle S2. Okay. Now from the figure, what is distance between C1 and C2? How you relate distance between C1 and C2 with radii R1 and R2? Obviously, distance C1 and C2 is greater than sum of their radius. So we have C1, C2 greater than R1 plus R2. We can consider this as a condition for two external circles neither intersecting nor touching. Now, how many common tangents can be drawn to these two circles? इन दो circles को हम कितने common tangents draw कर सकते हैं? For that we have this one cross. This is a set of common tangents. This set of common tangents is called transverse or indirect common tangents, which are intersecting at point T. We have other two common tangents also, like this. These are called direct common tangents. So in all, we can draw four common tangents. Now, to find the equation of these four common tangents, we require to find point of intersections of these tangents, points T and D. Let's see how to find these points using geometry of this figure. Okay, for that, consider this diagram. In this diagram, we had draw perpendicular to tangents. डायरेक्ट एंड इनडायरेक्ट कॉमन टेंजेंट्स के ऊपर हमने परपेंडिकुलर ड्रॉप किए हुए एम एन पी एन क्यू आर फीट ऑफ परपेंडिकुलर्स. Now we require to find point T and D. From the symmetry of circle, we can check points C1, T, C2 and D are collinear. Okay, to find point T, now we focus on these two triangles, triangles T and C2 and triangles C1 and T. Now what about these two triangles? Can we say these two triangles are similar? We can, because these two angles are same and this angle is 90 in both the triangle. So these two triangles are similar. Okay. Now triangles are similar. That means now we can compare ratio of their sides. That means C1T upon C2T. This ratio is equal to what? It is C1M upon C2N. What is C1M? It is radius of this circle R1 and C2N is radius of this smaller circle, which is R2. So we have this ratio as R1 upon R2. Now why we were interested in finding this ratio? Because to find point T, which is lying on the join of C1 and C2, if we can find ratio C1T upon C2T, we can find coordinates of point T using section formula. Now, from this ratio, we can say point T is dividing C1, C2 internally. In what ratio? In the ratio R1 upon R2. We have coordinates of centers C1 and C2. So we can now find the coordinates of point T as R1x2 plus R2x1 upon R1 plus R2, R1y2 plus R2y1 upon R1 plus R2. This is from internal section formula. Let's find now coordinates of point D. For that, we consider triangles C1PD and C2QD. What about these two triangles? Okay, what about these two triangles? Are these triangles similar? Triangles C1PD and C2QD. Clearly these two triangles are similar. Okay, so what we do, we can now compare the ratio of length of their sides. What is that? C1D upon C2D. This is equal to C1P from bigger triangle upon C2Q from smaller triangle. From the diagram, C1P is R1 and C2Q is R2. So this ratio is R1 upon R2. What do you mean by this ratio? C1D upon C2D is equal to R1 upon R2 from section formula point of view. This means point D is dividing the join of C1, C2 externally in the ratio R1 upon R2. So we can now find the coordinates of point D using external section formula. We know how to use this formula when the ratio is external. The coordinates of point D are now this one, R1 x2 minus R2 x1 upon R1 minus R2. Similarly, we have y coordinate. We know that when we have external section formula, we put minus sign. So we got coordinates of point T and D where common tangents intersect. When we need to find the equation of this common tangents, these points of intersections are required.